In this video, we're going to show you the process to set up a new job in Aspire, import a piece of 3D Clipart, alter its position, size and orientation, and then calculate a rough, finish and cut out toolpath in order to reproduce the part on a CNC. So let's begin by starting a new copy of the software. So we'll start by clicking on the option to create a new file. Now we come into the job setup form, and in here we're going to specify the size of the job that we're working on and also specify the datum position. That's the X, Y, Z, 0 position and where we're going to set that on the machine relative to our piece of material so that everything we create will be machined in the right place. For the width of this job, I'm going to set a value of 10. Height, I'm going to set a value of 10, so it's going to be a square job, and we're going to work with a piece of material which is 0.75 inches thick. I'm going to check here that the option for Z0 to be on the top of the block is selected, which it currently is, and we're going to set the XY datum position, that's the XY0 position, to be in the lower left corner of our job. I'm going to work in inches, and for the modelling resolution, which affects the quality of our 3D part, I'm just going to leave it set to standard. I'm going to come down and click on the button to hit OK, and now we come into the main interface of our software. To import a 3D model into our job, we're going to come down to the Modelling tab at the bottom of the interface. I'm going to click on that. Now we have access to all the icons that relate to working with 3D objects within Aspire. I'm going to click on the last icon on the first row here, which is Import a Component or 3D Model. That will open a window that lets us browse onto the disk of our PC, and here from the project folder that relates to this example, I'm going to choose a file. You can see the name of this is Magnolia Flower. We have a number A-3D clip. This is a special kind of 3D clip art file that we save from Aspire. But we could at this point be importing a variety of different file formats, including things like the Vectric 3D V3M file, and also files like STL files, Rhino files, or many other formats that you can see listed here. Here, as I say, we're importing one of the pieces of clip art that comes with Aspire. I'm going to hit Open, and we'll see in the 2D view that we get a grayscale preview showing us the position that the part's been imported into. The first thing I want to do is center that in the middle of my job. So I'm going to come over to the Modelling tab. I'm going to click on this icon here to align selected objects. By default, that will be selected when we've imported it here. I'm going to come up to the top. I'm going to choose the middle option, which is align horizontally and vertically within my material. So when we click on that, we can see that the software has moved our preview into the middle of the job, and that means the 3D object would also have moved as well. Let's just hit Close on the Alignment Tools form. As we're working with both 2D and 3D entities within this job, it'll probably help if we can see them both at the same time. So I'm going to come over here, and under 2D View Control, I'm going to click this icon to tile the windows vertically. That means I can now see the 2D representation on the left and the 3D model is shown on the right. Within this window I can click and move the mouse in order to rotate this around, or I can come up to the top here and I'll set that into what we call the ISO view. Before we create the toolpaths, we want to make sure that the part is positioned, sized and oriented correctly within our job. Here we can see we've centered it, so that's good. Now what I want to do is change its size, so I'm going to come over to the Transform Objects area on the Modelling tab and click on the icon here to set selected object size. Within here, I'm going to check the anchor is set to the middle. I'm going to make sure Link XY is checked, and I'm going to change the width to 9 inches. Because we have this checked, the link option, that will automatically scale the height for me, and if I hit Apply, then it will actually execute that change that we've entered. So there we can see that both the 2D and the 3D have resized for us, and we can go ahead and hit Close. Next, we could also go ahead and do things like rotate the part or mirror it. If we wanted to create a left and a right version, then we'd toolpath this version, and then we might come in and click on the mirror selected objects icon and click on flip horizontal, making sure we don't have either of these options checked. So if I click that, you can see that's just mirrored it left to right over the center of our part. The other thing we may want to do is rotate this slightly. If I come into here, might click on rotate selected objects, and then perhaps we'll just rotate this, say 5 degrees in this case, hit apply, and now you can see we're able just to rotate the part around a little as well. As well as editing our part by entering values into the functions of the software, I can also dynamically change it. If I click on it again, I go into what we refer to as transform mode, and here we can see these little white and blue squares have appeared around the part, and they're handles that I can use to dynamically edit it. If I click on the one at the side here and drag inwards, you can see we can scale that down horizontally, or perhaps if I wanted to click on the blue node, I can rotate that around. So you can see it's possible for me to make edits without entering hard values and by just using my eye and the mouse in order to make changes to it. In this case, I was happy with the way that looked before, so I'm going to come over to the Drawing tab. I'm going to click on the icon to undo that. I'm going to click on that again to undo it a second time and go back to how it was originally. Now I'd like to come back to the Modeling tab, and I want to make one last edit to the size of this part, and that's to adjust its Z-depth. We make sure the part's selected, which it currently is, and come up to the top and click on the icon to scale Z height of model. Within here we can either scale the height of this by using the slider here, so we can scale it up and down and that will automatically adjust, or we can click on the button to set an exact height, and in this case I'm going to set the height of this to be 0.55 inches and hit apply. We can hit close and I can hit OK over on the scale model height form, and now we've adjusted the height of our 3D object so that it's 0.55 inches from the base of our modelling plane up to the highest point within the 3D part itself. At this point I'm almost ready to start calculating toolpaths, but I do have one more job, and that is to create a boundary vector around the outside of my part. Again, we need to make sure that's selected. We can see it is because the grayscale is highlighted here, and also because the name of the component is highlighted in the component tree. I'm going to come up and click on the icon here to create vector boundary from selected components. And when we do that, the software has actually gone ahead and fitted a vector around the outside of our component edge here. So it's used this grayscale preview in the 2D to fit a vector around. If we zoom in there, we can see that if I select it, we just have that vector line now. Let's go back to fit the objects within the window. Now the vector is very important because that will limit where the toolpath is going to cut. If we don't have a vector, then the tool's going to go all over the flat area around the outside of the part, and in this case, because we're planning to cut the part out, that would be wasted time. So here we've created this vector as a boundary, and now we're ready to go over and start calculating our toolpaths. So I'm going to come over to the Modeling tab, click on the icon here to switch to Toolpaths tab. What that's going to do is hide my Design tab on the left, and on the right hand side of the interface open up all the toolpath functions on the Toolpath tab. The first job before we ever calculate any toolpaths is always to check our material setup. I'm going to come down and click on the button Set here. That's going to open the material setup form, and within here first I'm just going to check the parameters for the size of my material and where I've got my X0, Y0 position set. So we can see we have thickness of 3/4 of an inch, and we'd set up Z0 off the top of the block and the XY0 off the lower left hand corner. And I just need to make sure when I set up my CNC that that corresponds to these positions and the sizes that I've entered. Below this we have an important area that we need to use when we're working with 3D models in Aspire. And this is where we relate the position of our 3D object to where it's going to sit within the Z-depth of our material. If you remember, we've set our thickness of material to 0.75 of an inch. Our model thickness we just set to be 0.55 of an inch. That means we have a space of 0.2 of an inch to play with within the material, and where we can adjust that position in order to change its position relative to the top or bottom of the block. Now we could either do this using the slider here. So you can see as I slide this, the light brown area in the block shows me the position my 3D model will fill within that. Or I could set a specific value and perhaps tell the software I want a gap of exactly 0.05 of an inch above the model, which means I'm going to have a gap below the model of 0.15 of an inch. That's additional material that will be added below my 3D object that I can see within the 3D view. Now we're going to come down and I'm going to set my rapid Z heights. These are positions that the tool will pull out of the job if it needs to move to a new position in the toolpath at its full speed. And at the bottom here we set the home start position. I'm going to set this to 0.5. That's the initial position the tool will move to from wherever the machine is when you first execute the toolpath before it goes ahead and runs the particular toolpath that we've saved here. Let's go ahead and hit the OK button. At this point, we're ready to start calculating the toolpaths that will actually reproduce this 3D part on our machine. It's worth noting here that you should make sure that if you do plan to cut this, that all the values you've entered for the material and datum setup, for the safe Cs, and any parameters you put in for the tooling and the toolpaths themselves are appropriate to your machine, material and setup and are safe for you to cut this. Now there are normally 3 stages to cutting a part like the one we have here. The first one is to use a larger tool to machine away the majority of the material, and that's what we call a roughing pass. Next is a finishing toolpath, and that's where we're going to specify a small enough tool that will get the level of detail we're looking for, and that will just run back and forward over the part in order to give us the finished surface. Then finally we'll calculate the profiling toolpath, which will cut the part out. So what I need to make sure before I go in to calculate my first toolpath, the roughing, is that I have the vector selected here over in the 2D view, so I should be able to see this dashed line around the outside of my component. What's important is that I don't need to have a 3D object selected. The software doesn't use any selection of 3D objects when calculating the toolpath. All it does is look for any visible 3D components, and that's what the toolpath will be laid on top of. So any set of components that I could currently see in the 3D view is what I'm going to machine when I calculate the 3D roughing or the 3D finishing. However, the vector is important because that's going to act as this boundary to stop the toolpath machining areas that I don't want it to. So with our outline vector selected, I'm going to come over, click on the icon to create a 3D roughing toolpath. Here I'm going to click on the select button, and this is going to take me into the tool database. This is the area in the software that we can store a list of our tools and all the parameters associated with them, so we can choose them to associate with toolpaths as we create them. Here I'm going to choose an end mill, a 0.25 inch end mill, and I'm just going to take the default values here and hit OK. Next, within the roughing, we specify what we call a machining allowance. This is an extra thickness of material that will be added to the model so the roughing tool doesn't cut too close to the finished surface. This just gives us a bit of skin that will leave something for the finishing tool to cut, and also tries to reduce the effect we might have of the larger tool chipping our finished part. So here I'm going to enter a value of 0.04 inches, so that'll just leave 40 thousandths of an inch of material as an extra thickness over my 3D object. To rough the part, there are 2 different strategies we can choose from. Z-level roughing will effectively cut multiple pocket cuts, so 2D cuts that respect the 3D model to hog out the material around it, and that'll leave you kind of a stepped finish over the part. 3D raster will just go back and forward over the part following the 3D contours, and that generally will remove a bit more material but will probably take longer to cut. In this case we'll go with the Z-level option. I'm going to choose the raster X, so that's just a direction. That means it's going to cut along the X-axis and step over in the Y. And we're also going to have a profile pass around it, and so that'll, after it's done these raster passes, it'll profile around the part on that particular Z-level. Next, I have an important setting, which is a boundary vector offset. We've selected a vector for our boundary that's right on the edge of our 3D part. The 3D toolpath will always bring the center of the tool to the boundary, and what that means in this case is that the tool won't have gone far enough to machine down the sides of our job. So typically, if you have a boundary that sits right on the edge of your 3D object and you want the part to cut down the sides with the 3D toolpaths, then you need to enter a boundary vector offset that is at least as big as the tool radius plus the machining allowance. So in this case, I'm going to enter a boundary vector offset of 0.18 of an inch, so that will actually extend the boundary an extra 0.18 of an inch outwards, allowing our tool to roll down the sides of the part and fully rough it. At the bottom here, I'm going to change the name of the toolpath, and I'll call this 3D Roughing Magnolia, just to give me a hint of what this toolpath has been created on, and go ahead and hit the Calculate button. Now you can see the software has quickly calculated my toolpath for me. It's automatically opened the Preview Toolpath menu here, and you can see that that toolpath has been added to the toolpath list down the bottom here. So at this stage, we may well want to preview that and see exactly what it's going to look like. If I just maximize the 3D view so we can see a little better, I can move this around and you can see the different Z depths of toolpath we've created there that are going to rough this part out. But it's still not entirely clear what the 3D object will look like once we've executed this toolpath on the machine. Now within the previews here, I can come along and click on this button that says Preview Selected Toolpath. The software is going to animate the tool cutting through the material using the exact settings that we've set up within the toolpath form. Once this is finished, what we see is exactly what we should get on the machine if we were to go ahead and save this roughing toolpath now and run it in a piece of material. So I can look at that, see the steps that's going to leave. We can see how that's hogged away the majority of the material, so it's going to make it safe for me to go back with a smaller finishing tool and then machine away the rest of this to create the finished surface. So I'm going to go back to tile my windows. I'm going to go up to View, Tile Windows Vertical, so we can see the 2D and the 3D view again. I'm going to close my Preview Toolpaths form. I'm going to come back to the Standard Toolpaths tab here, and I'm going to make sure my vector's still selected, which it should be, and come over and click on the icon to create the 3D finishing toolpath. For a finish, we're normally going to use a ball nose cutter. That's a cutter with a round end. If I click on the select button here, we can come back into the tool database. From the ball nose section here, I'm going to choose a tool which is 0.125 inch ball nose. So we can see here that is a 1/8 of an inch diameter tool. There are some other important parameters within the tool settings here, particularly when we come to do finishing, and one of those is the step over. At the moment we have this set to 10% of the tool diameter, or an actual distance of 0.0125 of an inch. What the step over refers to is the distance the tool is going to move over between each pass of the toolpath. The way the finishing works is to move along in a straight line, and then at the end of that straight line to move over a little bit and come back over the 3D object, step over again, come back over the 3D object, and that's how the part's replicated. The smaller this value is, the closer together those steps are going to be, and the better finish quality we're going to get on our surface. A typically good value in order to assure that you're going to get a good quality finished surface is to go 10% of the diameter of the tool or less. In this case, we'll leave that set to 10%. I'm going to go ahead and hit OK. Now if I want to edit the tool values and have the software remember them, then I would do that in the tool database where we were just looking. In some cases though, you may just want to override the settings for one particular toolpath. We can do that by clicking on the Edit button here. You can see it's showing me that tool we just selected. If I wanted to, I could change the step over for this toolpath, or in this case, because of the material I'm planning to cut this into, I think maybe I could let it go a little faster. So I'm going to enter a feed rate of 120 inches a minute and a plunge rate of 60 inches a minute. And again, you'd need to make sure these values are appropriate for whatever you plan to cut. If I hit the OK button now, for the purposes of this toolpath, it's going to take on those values we just entered, but they won't be remembered in the tool database. There are two patterns that we can get the software to follow when it creates the finished toolpath. The offset pattern will use the vector we've got selected and essentially follow that shape, offsetting by the step over each time in order to cut over the part. We can control the direction it cuts by choosing between climb and conventional. The other pattern we have is a raster pattern, and this is where the software is just going to go in a straight line, then step over, come back in a straight line, so on and so forth over the whole of our 3D object. For that we control the angle. 0 degrees is going to be along the x-axis, 90 degrees would be along the y-axis, and any other value we wanted in there would be relevant to those two directions that we just talked about. The next setting is the boundary vector offset again. This is the same setting that we had in the roughing, and this just allows me to enter a value to make sure my tool is going to roll over the side of the part. Remember, the center of the tool comes to the vector, so as it's set up here, if I had a 0 boundary vector offset, then it's just going to end at the edge of the leaf. I want to make sure the tool comes all the way down the side, so I'm going to enter a value which is at least the radius of my tool in this case. So we'll put in a value of 0.08 of an inch. Now I can come down to the bottom here. I'm going to call this 3D Finish Magnolia, and we'll hit the calculate button. So what that's done, if we zoom in here, is create a toolpath that's going back and forward over the job, as you can see here, and that step over value we entered is what's going to dictate the distance between each of these passes and the quality of my finished surface. Let's go ahead and maximize the 3D view. Now you can see that the software's automatically opened the preview toolpath form here. Now we have the 3D Finish toolpath selected, so I can click on the icon to preview selected toolpath, and again the software is going to animate that tool. So now what we're seeing is the toolpath we've calculated and the finished part exactly as it will be in respect to the size of the tool we've entered and the marks that the tool may leave on the part based on things like the step over and the radius of its size. Now we can zoom in on this, we can check the finish, see exactly how that part's going to look, and if we're happy with that, we're happy with the quality of the cut and the fact that's going to look okay based on the parameters we've entered, we can go ahead and calculate our final toolpath, which is the cutout. I'm going to click back to the ISO view, come up to view, tile the windows vertical again, make sure this vector is still selected around the outside. I'm going to hit close on the preview toolpath form. I'm going to come up and we're going to calculate a 2D toolpath this time, the profile. So we'll click on that. Cut depth for this is going to be 0.75, so basically the thickness of the part. And here I'm going to hit select. I'm going to choose a 1/4 inch end mill, 0.25 inch end mill, and hit OK. Again, if we wanted to, we could edit this and change the values in it to override for this particular toolpath. So in this case, maybe I'm going to enter to do a pass depth of 0.25 of an inch, and that means that now it should be able to cut my depth of 0.75 in 3 passes instead of 6 as it was set before. So if I hit OK, we can see the passes update. Within here, I'm going to make sure I'm choosing to machine outside of that selected vector because I want to cut this out. If I wanted to, I could go ahead and add tabs to this in order to hold the part in place. As long as there was material below this that we're going to be profiling out, then it'll leave the tabs in there and I wouldn't need to make sure the part was secured another way. In this case, we'll assume we have a way of holding this down. I'm going to come down to the bottom and I'm going to enter a name that I'm going to make sure I recognize. I can hit calculate, and there we can see the toolpath that's been created. I can maximize the 3D view again. We can take a look at that by rotating the view around. So there's the 3 passes it's going to take to cut out this part. Now we can come up and click on the button to preview selected toolpath, and there we can see what the finished part will look like once it's been cut out. Now we can see if we look at the preview that has done a pretty good job, but there's a few areas where that tool has not been able to get in, and so it's left a radius in there. Now I might be happy with the way that looks and go ahead and just cut this anyway, or it may be that I'd like to try a smaller tool to see if I could get more of that material out of there. And this is what's really useful about the preview, as it gives me this opportunity to see this before I've gone ahead and used any material or time on the machine to cut it and found out it wasn't right. So let's assume we do want to change this. What I could do is come over to the preview and click to undo the last thing that we previewed. I can close this now, and then I could take my toolpath that we just calculated, come up and click on the icon to edit that toolpath, and now come and change this tool. So I'm going to hit select, and from the tool database let's choose a 1/8 inch end mill in order to cut this part out. Let's hit OK, and then I can just hit calculate. It'll recalculate that toolpath with the new tool and the parameters I had set for it, and now what we can do is preview that selected toolpath, and we can see how much more that's going to be able to clear out for me. So we can see that's really able to do a better job of getting into some of these corners here in the part on the cutout pass. Now if I was happy with that, I might want to take a look at the part in the preview here without this stock material in place. To get rid of that, I can just double click on it in the 3D view and it will disappear. And so now what we're looking at is a really good representation of how my part should look once we've actually cut it on the machine, assuming we do all the same setup as what we've specified within the software. If I am happy with it, we can close the preview now and we're ready to save our toolpaths and send them out to the CNC. To save toolpaths within Aspire, we just select the toolpath we want to output, come up and click on the icon here to save toolpaths. We make sure that the right toolpath is in the list here, and then we'd come down to the post processor drop down here, and here we're going to select from a large list of machine tools and control software that are available within the software that will format the code that we've created in here in a way that the machine's going to be able to understand it. So here we might just want to output some standard G code. Now when I hit save toolpath, we're going to take that roughing file, I can enter a name for it, choose a place on my PC, hit the save button, and that's going to save the data in a format that I would actually be able to then put on a memory stick or maybe copy across a network and load into the control software on my machine and cut that roughing toolpath. To output the finish, I'll just click to select it. Again, make sure I have the right post processor selected to format this. It'll remember this once you've set it once, so if you get that correct, you shouldn't need to set it again. Click on the save button, give that an appropriate name, save it, and again my finishing toolpath would now be ready to take over to the CNC. Finally, we'd select the profile, hit save, give that a name, and we'd have the toolpath that's going to cut the part out for us. And all we'd need to do is make sure on the CNC that as we ran each of those toolpaths, we changed to the appropriate tool and we made sure the XY0 position was consistent and that we reset the Z0 position between each of the toolpaths as well. That way everything should run in the correct place and we should end up with the part that we were looking at in the preview. Let's just go ahead and close the Save Toolpaths menu. Now the other thing we'd want to do at this stage is to save our entire part. That would save all the 2D information and all the toolpath information in a file that we could open at a later date in Aspire and make edits to if we wanted, or we could open it just to check some of the values if we needed to. So to do that, we go File, Save As, and then within the project folder here, I'll just save this as Magnolia tp.crv3d. .crv3d is the Aspire file extension. The TP is just something I use in the name to show me that it's got toolpaths in this file. So if we hit save now, you could always open that from the project folder and take a look at it. So let's take a moment to summarize what we've looked at in this example. We started by creating a new job in Aspire and set that to be appropriate to the size of part that we were planning to cut. We then imported a piece of 3D Clipart, we centered it within our material, and then we adjusted the size and orientation until we got it to the point where we were ready to start calculating toolpaths. Before we went over to the toolpath side of the software, the last thing we did was to fit a vector around the outside of it to act as a boundary for our toolpaths. Then we went over to the Toolpaths tab, we checked our material setup, and then we calculated a roughing toolpath in order to hog out the majority of the material around the part, a finishing toolpath in order to create the final finished surface, and a profile toolpath in order to cut the part out. We previewed the toolpaths, we decided that we wanted to make a change to the profiling and use a smaller tool, so we were able to see that we wanted to do that before we'd actually saved anything to the machine. And then finally, once we were happy with the way the preview looked, we were able to save the toolpaths, choosing an appropriate post processor in order to format the data for our CNC. And that concludes this video.